All right. So again, yeah, we're talking about transformations of linear functions. Transformations of linear functions. Straight line functions. Now, remembering all of our transformations, we've got stretches, compressions, shifts, left to right, whatever. Now, here's what I'm going to do. You don't see any of the transformations that we're going to go through on your paper right now. Because I'd like you to kind of make a master list for yourself on the back, since there's nothing on the back. And that's how I like to run this section. Because I think it would be kind of important to have sort of a master list for yourself, and it's important to write those out each time. Okay, so let's remember what these transformations are. Remember, there's two types of transformations. There's rigid transformations and there's non-rigid transformations. There's ones that preserve congruency, and then there's ones that don't preserve congruency. The ones that preserve congruency are the reflections and the shifts, up or down, left or right. The ones that don't preserve congruency, those are the ones that are the stretches and compressions, whether that be vertical or horizontal. So we learned all about those transformations, and we learned in chapter 1 that any type of function that can be created is basically a transformation on the parent. Okay? Any type of function that can be created, any linear type of function that can be created, is a transformation on the parent. What is the parent linear function? Y equals x. Just that, right? Y equals x. Any type of linear function, any line that you want to make, is a transformation on the linear parent function. Okay? So, the first two that we're going to talk about are the horizontal shifts and the vertical shifts. Okay? So on the back of your paper, you're actually going to start on the back. On the back of your paper, I don't want a crayon, I don't want a highlighter there. I'd like you to put a shift left or right, and then this rule. Okay? And I'm going to write on the whiteboard, I'm going to use this nice fancy green marker. I'm going to make the master list just as I would like you to make it on your back of your paper. Okay, here are the transformations. Okay. And then over here, I'm going to write an example. All right, so the transformations. The transformations are, the first two that we have, are the shifts. It's really like 4, because you can move it left or right, and up or down, but you get the gist. Okay, so horizontal translation. Let's call it horizontal shift. Horizontal shift. Okay, that's going to take f of x and map it to f of x minus h. Okay, that's going to take f of x and map it to f of x minus h. What does that mean in function notation? That means I'm going to take the function and I am going to change change the input value, and that's what that says up there, right? Change the input value from x to x minus h. Okay, so I am going to do an example. So here are all the transformations. I'm going to do an example on a particular type of function. I don't know, I'm just making this up. 2x plus 3. So f of x is 2x plus 3. Okay, 2x plus 3, sure. Okay, if I wanted to shift it, let's go, what do you guys want to do? Let's go right 4. Right 4. That sound good? Right 4. That would mean I would take f of x and map it to f of x minus 4. Right? F of x maps to f of x minus 4. Again, think about the function notation that I've got going on here. That means in my x value, in my function, I remove the x value, and what do I put in its place? X minus 4. Okay, so that means my new function, we'll call it a new function g of x. G of x is 2 times no longer x. X gets removed. in its place goes x minus 4. Do we all see what I'm doing there? This function notation says, okay, this was f of x, the function when it's x. I want a new function, and I'm going to call it f of x minus 4, which means I'm going to plug in x minus 4 instead of x. And now I just have to reduce it down. So g of x is going to be equal to, this would be 2x minus 8, right? 2x minus 8 plus 3. I just distribute the 2. And so I combine like terms, 2x minus 5. Do we see that going to the left would be the exact same thing? However, what would go in my parentheses? Like if I made this a left 4 instead of a right 4. What would go inside my parentheses then? It wouldn't be an x minus 4, it would be a what? An x plus 4. But then it would follow the exact same way. Okay? Now, the next one, vertical. Vertical shift. Okay, for a vertical shift, f of x is going to map to f of x plus k. That's a k, couldn't tell. Okay. F of x plus k. Now in this case, the output value is going to change. What do you guys want to do? Up or down? Up how much? 2. Up 2. Okay. Up 2. Okay, I'm going to take this function that f of x is equal to 2x plus 3. And the rule says f of x is going to go to f of x. Okay, if I'm going up 2, it's plus 2 out on the end. Notice that my input value is no longer changing. In the last one, I removed x, and in its place, I put something else. The reason I did that is because it was something horizontal, something that changed the input value. But I'm not changing the input value with the vertical things. I'm changing the output value. I'm just basically taking whatever f of x is, and I'm tacking on plus 2. So let's do that. So now, let's call it our new function, g of x is going to be equal to f of x, 2x plus 3, and then I'm just going to add 2 to that function. Bless you. Bless you. Detention. So I just combine like terms here and then finish it off to say a 2x plus 5. Does that make sense? I'm not changing the input value. I'm changing the output value. I'm tacking on something to f of x. Changing the output. This was f of x. 2x plus 3 was f of x. And then I just add on the plus 2. So 2x plus 5. Okay. Let's talk about the reflections. Now, reflections across the x-axis and reflections across the y-axis. Reflection across the y-axis is a negative x. Reflection across the x-axis is a negative y. And I'll scroll it down there in a second. Okay, so that means we've got reflect over, we'll do the y-axis first. It's going to map f of x to f of negative x. I'm changing the input value again. Why does the input value change? Because again, if I'm reflecting across that vertical axis, I'm changing the horizontalness of it, right? I'm changing the left and right of it. So I've got to change the x value. So what does that mean? We're going to take f of x and map it to f of negative x. So that's going to get us to g of x is, okay, look at the input value. It's no longer x, it's negative x. So it's 2 times negative x plus 3. I input negative x instead of just x. And that reduces to negative 2x plus 3. Okay. If I reflect over the x-axis, if I reflect over the x-axis, let me still see that. Is my podium going to be in the way at all for you guys? Very cool. Is my podium ever going to be in the way? No. We're going to move it forward. That's going to take f of x to negative f of x. So that means, again, the rule is f of x. I always like to write the rule out again. Negative f of x, right? That's changing the y value, changing the output value, right? So that means I'm going to take negative of my entire f of x. So g of x is going to be negative of the entire f of x. This has to go in parentheses, 2x plus 3. Don't get me wrong, I'm not changing input. I'm just doing something to the entire f of x. That's why it goes in parentheses. So negative 2x minus 3. Okay. Let's practice that a little bit. Okay. Flip it over on the front. Okay, let g of x be the indicated transformation of f of x. Write the rule for g of x. Now, whenever it says write the rule, what I'm talking about there is like write the equation of f of x. Or, excuse me, write the equation of g of x after it's been transformed. Simplify it all down. Okay, so we're going to perform a right 3 on this function. Okay, we're going to perform a right 3 on that function. Okay, I didn't choose the right 3. So my rule for horizontal translation right 3 is going to be f of x is going to map to f of x minus 3, right? I know it almost seems counterintuitive that the right is actually going to be a minus, but that's true. So if it's going to go to the right 3 units, it's going to be an x minus 3 being inputted in. So now my g of x, so this is saying let g of x be the transformation. So let g of x be our new function, our right 3 function. So g of x really is x minus 2, oh wait, not x minus 2, x minus 3 minus 2. Right? I remove x out of the function, and in its place, I write x minus 3. That's what this notation means up top here. Okay, now I just simplified down, so g of x is equal to x minus 5. And that's my final answer. Questions about that? If you are ever wondering whether you got this answer correct, you could graph it. Graph it in your calculator. Watch x minus 2 go by. Then see if it actually went to the right 3 units when you graph the new one, x minus 5. Do this again now in a different way. Use the table provided as your original function and reflect across the x-axis. Now, how do we create the function? How do we create the function given the table? Oh, wait, if it's linear, we've done this before, right? How do you create an equation based on a table? Well, what's my slope? My slope is going up 2, up 2, up 1, up 1. What's my slope in this case? 1/2. Y over x, right? So the slope is 1/2. What's my b value? What's my b value? Always pay attention to the table. Sometimes I give you the y-intercept. Don't do more work than you have to. Could I do the whole solve for b method to figure out what my b value would be? No pun intended. I could, but I don't need to here. My b value is 1. 0 comma a number is always the y-intercept. So that means my equation is y equals, or let's go f of x. F of x is equal to 1/2 x plus 1. Okay, so now we're going to reflect this across the x-axis. Reflecting across the x-axis changes the output value. It turns f of x into negative f of x. Okay, so let's take our answer as g of x is negative our entirety of f of x. The entire function f of x gets turned opposite. It's turned on its head. Not really on its head. That'd be like reciprocal. So g of x is equal to negative 1/2 x minus 1. Don't believe me? Graph it. See if that actually happened. All right, so now, any questions on that before I jump to the next slide? Okay, sorry. Didn't ask before I moved on. Stretches and compressions change the slope. Okay, that's going to be key here to remember. That stretches and compressions, whether they're horizontal or vertical, will change the slope of the line. They're going to change the pitch, the slope of the line, the rate of the line. If the line becomes steeper, the function has been either stretched vertically or compressed horizontally. If the line becomes flatter or shallower, the function has been compressed vertically or stretched horizontally. So let's take a look here. Okay. These are the stretches and compression rules. Here is my horizontal rule, and here is my vertical rule. They're actually the same for stretches and compression. Okay. So let's do horizontal first. Horizontal, stretch, or compression is going to be f of x is going to map to f of 1 over b x. So again, it's going to change the input value. We learned that before. It's going to change the input value. But how does it change the input value? It's going to multiply it by a value that's the reciprocal of b. So if I say it's a horizontal stretch by 3, I'm actually multiplying it by 1/3. Okay. If I say it's a horizontal stretch by 5, I'm actually multiplying it by 1/5. So 1/5 inside the parentheses. What would happen if I wanted to horizontally compress it by 1/2? What would I be multiplying on the inside? 2. So if it's a whole number, I'm actually compressing it, right? If it's a whole number being multiplied inside the parentheses, I'm actually compressing it. All right, so again, so this is going to map to, what do we want to do? You guys get to choose. What do you want to do, a stretch or compression? Stretch by what? By 8. Oh, chicken nuggets. So we're going to horizontal stretch by 8. Okay. So that means that's going to be an f of x is going to map to f of 1/8 x. So again, 1/8 goes in, right? 1/8 x goes in. So my new g of x is going to be 2 times 1/8 x plus 3. Okay? It doesn't change the y-intercept, which we learned before. Horizontal stretches and compressions never change the y-intercept. See, it's only going to affect the slope right here. So that's going to be, okay, 2/8 would be 1/4 x plus 3. 2 times 1/8 is 1/4. What did it do to the slope? It took it from 2 to 1/4. Horizontal stretch. Stretched it out. Flattened the slope. Okay, and then our last one here is a vertical stretch or compression. Vertical stretch or compression. Now that one is a little bit more straightforward. A times f of x. I don't do anything to the a value like I did with the reciprocal on the horizontal. It's just f of x is going to map to a times f of x. Okay, what do we want to do? A stretch or compression? Compression? By how much? So like a 1/3? Yeah, if we say compression by 3, that doesn't make sense, right? We would have to say like a stretch by 3, right? So we say a vertical compression by some sort of fraction. Vertical compression by 1/3. Sound good? So V comp by 1/3. Okay, so that's going to take f of x and map it to 1/3 of f of x. Okay, that's take the number straight as it is. A times f of x. So that means we got g of x is now 1/3 of 2x plus 3. Ooh, we were nice to me. Because now when I distribute into 1/3, 2 times 1/3 is going to be 2/3. That's easy. And then 1/3 of 3 is 1. 2x plus 1. Okay, let me let you in on a little secret. This left side of this table will never change throughout the entire year. Okay? This whole left side of this table does not change throughout the entire year. I will reference this a time and time again. What will change throughout the year is the right side of this. How does it apply to each transformation? That's what we're going to look at throughout the year. Okay, let's do a couple more examples. Let g of x be a horizontal compression of f of x, where that function is negative x plus 4. And we're going to horizontally compress it by a factor of 1/2. And horizontally compress it by a factor of 1/2. Okay, so that means, what's my rule? F of x maps to what? Horizontal compression by 1/2. Horizontal compression by 1/2. What's gonna happen? We can do this. We got this. You don't need me on this. Come on now. What do we think? Horizontal. Looks like I know. Horizontal compression. Okay, where is it at? Right there. Horizontal compression, right? Okay, so that means it's going to be 1 over b of that value. So b is 1/2, right? So what's the reciprocal of 1/2? 2. So this is going to be f of 2x. The horizontal things are when the weird stuff happens. Like it's the opposite of what you think. Going to the right is actually a minus. And it's the reciprocal. Okay? Additive inverse, multiplicative inverse when you're working with horizontal stuff. Okay, so what does that mean in terms of this function? Now g of x is going to be equal to, I'm going to input 2x where x was, negative 2x. I know I don't need parentheses right there, like that's overkill a little bit. But I'm just showing you, you're plugging in 2x. So g of x, the final is going to be negative 2x plus 4. It does not change the y-intercept. Anything horizontal does not change the y-intercept. Horizontal special compression, right? Shift command, yeah. Okay, let's keep going. Oh, it says to graph the function. I'm sorry, I wanted to show you what it looks like to show you how to check it on your graphing calculator, okay? Because it's really beneficial to see that. If you go into your y equals, sorry, I'll give you a minute to get it calculated. But if you go into your y equals and you graph the original, negative x plus 4, and then you graph your final, negative 2x plus 4, what should you see? Visualize it before you hit graph. Horizontal compression, pushing it toward the y-axis. Let's see if that actually happened. There's my original. There's my new. Did it push it toward the y-axis? Yeah, it's confirmed that it did press it toward the y-axis. This was F, and this was G. So you can always check that to make sure it's happening the way you think it should. Let g of x be a vertical compression of f of x. 3x plus 2 by a factor of 1/4. All right, well, if it's a vertical compression, what's f of x going to map to? What's f of x going to map to? Vertical compression by 1/4. Vertical compression by 1/4. F of x is going to map to what? Joey, you got this.
1/4 minus f of x.
Times. Sorry, that's a times. 1/4 times f of x. Yeah, that's a vertical compression by the factor of 1/4. Okay, so g of x is going to be equal to 1/4 of the entirety of f of x. Okay, f of x was 3x plus 2. Again, please don't think that I'm changing an input value just because you see parentheses. All I'm doing there is just saying, okay, 1/4 has to be applied to this entire function, this entire f of x. So g of x is going to be 3/4 x. 3 times 1/4 is 3/4. 1/4 times 2 is 2/4 or 1/2. Let's graph it to confirm. My original y was 3x plus 2. I almost did for it. 2x plus 3 over. And then the new is 3/4 x plus, I'll say 0.5. Okay, again, visualize. What should I see? I should see a vertical compression. I'm going to graph my old, and then it's going to vertically compress. So here's my old. There it goes. Pushing in toward the x-axis, right? Yeah, I can confirm that here was F, and here was G, vertical compression. Last one here. Oh, wait. Did you see that? No. You guys have this one though, right? Mm-hmm. Oh my gosh, I'm just hunting. Oh man. Whew, I'm losing it. Let g of x be a horizontal shift of f of x is equal to 3x. Left 6 units followed by a horizontal stretch by a factor of 4. So now we're chaining it together. Okay, we're putting one on top of the next. We're making two transformations in one. Okay, so this means I've got my f of x is 3x, right? What would be the rule for a left 6? What would be a rule for a left 6? What would that be? Plus 6 on the inside, right? F of plus 6. Okay, because if I'm going left, it's actually a plus on the inside. So that means my kind of halfway there, g of x, this isn't final g of x, but halfway is 3, and then I'm going to take out x, and in its place, write x plus 6. So g of x is 3x plus 18. That's halfway there. Now, the rest of the way there is a horizontal stretch by 4. So now f of x is going to map to, okay, horizontal stretch, f of 1/4 x. Remember that horizontal stuff is weird. I now take it inside and take the reciprocal. So my final g of x, chain it together, removes x here, and in its place writes 1/4 x. So we get g of x is equal to 3/4 x plus 18. You can cross out that last problem. We're not going to do that. Not even in my notes. All right, so here are all of our transformations, and here they are applied to the linear function. Okay, that's really what we're working with in this chapter. All right, So long to the folks at home.